What we're going to do is we're going to have a session in Agile Analytics using AzureML. If you're in the wrong session, now is a good time to leave, just in case anybody is. All right, so I understand the session lasts about 90 minutes, so I've got a mix of PowerPoints to go through, but I've also got some demos as well. I'm happy to take any questions at any point. If you need a pen or paper, I've got some down the front here, if anybody needs it. If anybody needs and runs out. Yeah, of course, there you are. Rather fetching, nice stable point. Take a couple because it'll be true to form. The first one won't work. Yeah, sure. There you go. Thank you. Yeah. Yeah, I'll leave them down the front. Just help yourself. I know everyone just move around. You know, take what you need. Let's move this over. Okay, so the first thing I'd like to talk about, first of all, is what actually is machine learning. And just to put that into context, there are a number of machine learning technologies you can use. AzureML is just one of them. And then we're going to talk about a framework for using when you're doing machine learning. What I have found in the past is when I deal with customers, they will very often say, I want you to build me a neural net. I want you to give me some regression or something like that. And then what I realised very quickly is that they don't have a business question in mind. And what that means is they're trying to use the technology without any real purpose. And the thing there is that when you're trying to build something, you're trying to do it in order to add some business value somewhere. I could build you a wonderful neural net, but it might not tell you anything because it's not set up in order to answer any particular question. So what is machine learning? Now, at the moment in the world, we've been dealing usually in Excel in a lot of cases. Excel is human scale data. It's rows and columns. We're very comfortable with the size of it. But then what we find is the way the world is going at the moment, we're starting to see machine scale data. Now, as humans, we have our working memory. We tend to chunk things, but we can only hold so much in our memory at any one particular moment in time. We are used to summarizing. We're used to trying to make things easy for ourselves. We don't remember billions and billions of data points that have been thrown at us over a second. We don't work like that. That's why we have computers to do it for us. So we're living in a world of machine scale data. So in order to deal with machine scale data, we need machine scale solutions in order to deal with that. In business intelligence, we often deal with very simple data aggregations. So I'll speak to customers, I'll say, what would you like? And very often they just want to know top 10 this, average that. So when I start a project, I'm expecting the customer to be wanting really complex things, but very often they don't have the basics in play, never mind anything more complex than that. So machine learning allows us to do the simple stuff, and also allows us to do more complex and more interesting data patterns as well. So I've been doing some work recently, and I've been helping the NHS with some of their data, and we've managed to find some really interesting insights, which I really think will go towards improving patient care. We're obviously trying to operate in such a way that we've got the patient very much in mind. And when we start to look at the data, things that might pop out at us that we didn't see before. So, what is AzureML? Now, I'm assuming that most of you here are actually very familiar with business intelligence. That's what you tend to do. And normally in business intelligence, we deal with data. We produce some sort of business rules on the data, and then we output that data in some form. Now that's very broad brushstrokes, very technology agnostic way of looking at it. When we look at AzureML, it's actually pretty much the same thing. We are dealing with sources of data. We're doing things with that data. We're implementing and searching for rules in the data. Then we're visualizing the data as well. So in order to do that, I found it useful to look at different frameworks that give us a background or a backbone in order to operate when we try to do these sort of programs. Now, business intelligence should be all about the business, the clues in the name, but very often I find when I do a BI project, it's all about the technology and the business gets forgotten. But with the CRISP DM model, you find that the business questions and the business users are very much at the forefront and front and centre of the programme, which is where it should be. I've seen very large business intelligence projects fail, and the reason for that is the users get lost in the process. They don't adopt it because they were sort of divorced from the process as they went along, and because of that, the BI project ultimately fails. If you do a quick Google or Bing search for why do business intelligence projects, the next word that comes up is fail in the auto search, and it comes up with something like 26 million hits. Yeah, and there's lots of reasons for that, and one is that it's all about the people. So CRISP DM, you can go and download the organisation that devised this. It's called the Modelling Agency. They've produced a very, very detailed PDF on how you can actually implement this in your own organisations. So if I were you, I would really strongly recommend that you read it. It's not just relevant for machine learning, it's also relevant for BI as well. Something like this is a very simple way of explaining what you're doing to the business users. So the first thing is always about the business question. The second thing is about the data. How well do people understand their data? I don't know about you, but I very often find that business users don't understand the data. That's why they will come along and they will ask you for 5 years worth of data in 160 columns or something like that. They will ask you for the whole thing. The reason for that is they don't tend to know what business question they've actually got in mind, and that's fine. You can do some searching around for that. But very often the data is missing. So I did some work for the NHS a little while ago, and I found that there was 5 years of data missing for one particular hospital, and I couldn't understand why that was. And it turned out, I thought someone had lost data, so I reverted to sort of DBA mode, looking, well, where is it? We've lost data here. And then I went to the customer and I said, there's 5 years of data missing, I can't find it, for a particular hospital. And it turned out that the hospital had actually closed for 5 years. The data was merged with another hospital as patients were transferred over. And then the hospital reopened after some refurbishment, I suppose. And then the data was split back out again. So that was why I had a whole tranche of data missing for a hospital. But until I asked the question, there was a very reasonable business answer why that data was missing. So sometimes just looking at the data is actually a very, very good way of seeing the pit holes in the organisation as well. It allows you to see more about the context of the data. So another example I have there is I inherited a team who were SSIS developers, and I went in and one of them was leaving within about a week or so, and I went through the SSIS packages. I wanted to understand better the processes, how the team were working, how aligned were they, did they check code in, did they do continuous deployment, how did they work? And the packages were extremely bloated. They were all different depending on which developer did it. And what I found was one of the packages wasn't working, and because I found the problem, it meant I had to fix it. So I inherited it by default because I'd opened the thing. So I opened up a package and I spent 2 days going through it, and it was a very bloated package. I understood why nobody looked at it for some time. It turned out it looked at 7 data sources. It was looking at Oracle, it was looking at SAS, putting the data allegedly into SQL Server. But the point at which the insert was happening, it was actually, there was a select module in there. And the reason that no data was getting across the SQL Server was because the developer who built it could not get the insert working. You know, you've got all those parameters in SSIS, they've got to match up exactly right or they don't work. He'd fell into that problem. So, but the problem there, the process, was not in place to check that that's what he'd done. There was obviously no UAT. The package had never inserted data into SQL Server at all, because according to my memory, if you a select does not insert data anywhere. So looking at the data will tell you so much about the organisation. So then we get into the sticky topic of data preparation. Any data science project will take about 80% of your time in cleaning data. It's just that's how it is. The data will be coming at you in different formats. Some of it will be structured, some will be unstructured. You'll get JSON data as well. As an aside, Azure will accept JSON data. SQL Server 2016 has now got the capability to deal with JSON as well. Yeah. So JSON's very much on the radar. The one thing I would say, if you are transferring data across the network and it's JSON data, what I have found is it can cost a lot more in terms of network traffic using JSON than it would do using binary. It was about a fifth I found when I was testing it. And what I had to do was use Google Protobuf. Protobuf is, you can use .NET as well. And you can actually take the JSON, crunch it down into the binary, transfer it across the network, and then put on a service at the other side that will take that data and burst it back out again into JSON so that Azure can get it. So there's things that you can do to get data in and out of Azure, but JSON is a very key thing at the moment. But when we're preparing data, you'll find there's all sorts of errors in there. Anyone who's tried to put data together in Excel will know that. There's a new tranche of technologies which are now available to help you to deal with data preparation. Self-service data preparation is a bit like self-service ETL. You let business users loosen the data and they can start to really grab it and try to work out what the problems are for themselves. So you might want to look at Trifactor, Pixata, Datamere. These sort of tools will help you to prepare the data better. Sorry? Trifactor. I'll write them up for you if I have a marker. Hello, thank you. So we've got Trifactor. Datamere. The leaders at the moment seems to be Pixata. And you've also got Clear Story Data. So data preparation has become such a problem that technologies are now springing up in order to deal with it, and they are getting a lot of funding from venture people. So it's worth having a look at what's happening in that space. And we start to look at modelling the data. I've got a whole section on how to choose models. But the idea of a model is it's basically you're trying to take your data and find a pattern that fits your data. That's what the model is for. Then we get methods to evaluate your model. How well is it performing against your business question? Because it might be performing terrifically well, but it might not be answering the business question that it was supposed to answer. And then deploying the model to production. Because eventually you want to put that model and deploy it in such a way that the organisation can actually use it effectively. So a quick summary, we've got the main thing here is about understanding the business question and understanding the data. Once we've done that, we can start to prepare the data. So coming back to my example of the hospital, where the data was missing, I could then take steps to worry about that. Modelling the data, and as I say, I've got a section on that, but I think the most important thing is try different models, and your model should depend on what it is you're trying to do. Evaluating the model, how do you evaluate it, but then also how do you tell the business people, the business users, how the efficiency of the model in such a way that it doesn't patronise them, because that can be difficult as well. And then how do we deploy the model? So we can see, that these steps actually fit quite nicely onto what AzureML does. So the data part of it, we've got understanding the business and understanding the data. So that's a crucial thing for AzureML. We'll talk about data sources in a while. Then we've got the modelling part, which is the core part of AzureML. So that is modelling, preparing the data, and then evaluating that data, that model as well. Then we've got the purpose of deploying the data. How do we actually make it production ready? Okay, so a quick summary, what is machine learning? We've talked a bit about that. It is a technology which goes in and out of fashion. It also can be called data mining fairly interchangeably. At the moment, machine learning seems to be the key marketing term, so that's the one that you hear. Data mining is supposed to be the more business-friendly one, but I don't hear it being called that at the moment. It used to be called search technologies. So my very, very first job a very, very long time ago when I graduated was I was an artificial intelligence consultant, and then did that for 5 years. And then the market changed, the IT bubble came in, and it became harder to get a role in such a niche topic, because by then artificial intelligence was no longer a trendy term, it would be called search technologies. So I blame Google for that, that's what they did. So then it's come back into fashion again. So lived through a whole cycle of technology. So what's AzureML? Now, when you look at some of the other technologies available to you, you've got Google, who give you machine learning. You can go off and look at their stuff. You've also got Amazon as well. Now, I did a survey for a customer a little while ago. They asked me to recommend a machine learning solution for them. So I had a look at the various solutions that were there. There's a lot. And then it really came down to whether we used Amazon or used AzureML. And I actually recommended AzureML for them. And the reason for that was it was much more business friendly, and it was also much closer to the skill set that they already had in-house. Now, things will probably change in Amazon. I think will become a bit more user-friendly for people to pick up. But there was quite a big on-ramp in order for people to understand it. It seems much more developer-oriented rather than AzureML, which is a bit more business-friendly. And you'll see that when we look at the interface. So sometimes choosing a technology is not all about the niche features that they will all give you. It's about what's the fit like with the ecosystem of the organisation as well. And we also talked a little bit about the CRISP DM model as a framework for helping you to talk your way through that project and in a way that the customer will actually understand. So what is ML Studio? Well, it's actually a way in which you can build your experiments. I'm going to take you through the interface in a moment. It's easy to use. It's a lot of drag and drop. I'm assuming most people here have used SSIS. So it's very much like that. You're dragging and dropping tasks on a canvas. The idea is business users, but I'd say probably tech-savvy business users and data scientists. You've probably lived through terrible experiences where business users have done terrible things in Excel, and if you give them even more data and even more models to damage their data, that could be a big cleanup job. So I would think twice about giving it to a naive business user. It's not Excel. It's not as easy to see where the errors are. And also it costs to run experiments, and you don't want to keep paying because the business users have done something really terrible in there. So the end result is a web service which we can consume in Excel, and we'll look at that before the end of the day. So who is ML aimed at? I'd say it's aimed at people who are familiar with data science, familiar at least with the process of data science, used to interrogating data, have a good understanding of the data and the algorithms. AzureML will help you get there because it has its own tasks and it has its own models. We can use R. I tend to use R more than the inbuilt models. There's a few reasons for that. We'll cover in more detail in a while, but it's basically in R. I can use tools like RStudio that will help me to develop tools more quickly on a small amount of data. I can do it on my laptop, and once I'm familiar and happy with the script and how it works, I can then start thinking about putting it into AzureML. It's just a sort of develop, dev, test, deploy sort of method that I'm using there. So business savvy users with no data science background, they can use it, but they should be very, very careful about testing. That applies to any project, but particularly if it's doing something that you can't quite see or explain because it's already programmed for you. Okay, so I'm just going to take you a walk through AzureML. We'll have a quick look at that. So I'm just going to end this show. Hello there. That's okay.
So I've got one question.
Mm-hmm.
So is machine learning, is it the same as data mining? Do you
Yes.
use both terms?
Yeah. Pretty interchangeably. There is a slight difference between them. It used to be, in the olden days, data mining was a more business-friendly term, and machine learning was a more statistics-laden term. But I think what's happened is that marketing people have got hold of it. Yeah, so, but technically there is a slight difference, but actually now it's all, if you look on Twitter and do a hashtag search, machine learning is the hashtag of the day, data mining not so much. So if that's your barometer of what people are using, that's what I tend to see it anyway. So I'm just going to start up Zoom it because I like it. Helps me to see what's going on anyway. Let's make sure that works. Yeah, good. Right, I'm just going to increase the size of the browser so that you can read it a bit better. All right. Okay, thank you. So what we have here is when we start up something new, there's a whole bunch of experiment templates which we can use in order to get something up and running. I suggest that if you're interested in learning AzureML, you just play with some of the templates and see how they look. It's a very safe environment. If you mess up the templates, it doesn't matter. Just delete it and then download another copy of the same template. It's not going. I don't know how you learn. I tend to learn by breaking stuff. So I like to go and try it. Something breaks, then I know not to do that again. But I don't tend to read instruction manuals. I have a terrible. I don't know if it's an attention span, but I can't follow instructions either. So using the templates is a great way to learn. And there's all sorts of different examples here. So I'm not going to ramp up any of these. But what we can do is you can have projects as well. So the thing with a project is that it's just a nice way of collecting all of your work together. It collects together all of the assets. So what I'm going to do is I'm going to call this code node. I'm going to click OK. Then I get little project. Then I can add assets to it. And here's the really interesting thing with AzureML. It has a whole range of quite simple-looking, deceptively simple-looking tasks that we can use to string together in order to create an experiment. So the first thing we need to do is have our data sets. You can see I've got quite a few data sets there. There's a whole ton of these. Some of them are sample data sets which are already in AzureML, and others you can actually upload, and I'll show you an example where we do that. So in SSIS, for example, we call it a package. In AzureML, it's called an experiment. So that when we talk about an experiment, that's a key term in AzureML, and that's all it is. Using your data, doing something with that data, and then outputting it, that's called an experiment. You can see I've got quite a few experiments in here.
Sorry, with the data sets, can you connect directly to Azure SQL database?
Yes, I'm going to cover that in a little while. Yeah, yes, that's right. Because we want you to use Azure. So, no, it definitely does. I'll show you. You can input and then output as well. So when we actually create a model, eventually you want to deploy it to production. So we call that a trained model. The model has been trained. And there's a whole process about testing and training models, and that's like your finished result. But when you train a model and mark it as complete and it's gone to production, I recommend you keep an eye on it, because what can happen is your model will stay the same, but your data can change. I don't know if anyone's ever read any of the work by Andy Grove, who headed up at Intel for 30 years. If you haven't, his book's amazing. He talks about the difficulties of keeping Intel relevant when the industry was changing so much. And he talks about the internal and the external factors in any business and how the business has to respond. So some of these are internal factors like staff changes or legal changes that affect your data and your organisation. Some of these are external factors. Something happens in the news that affects your organisation, or it could be an external factor in your customers. They no longer want your product. So how do you change and adapt so that you give them something that they do? So Andy Grove talks about the external, internal factors, and these are very important when you start to think about what happens to my model once it's in production. How can I keep that relevant? And I wrote a blog post on it a while ago. If you have a look at some of these external factors, keep an eye on them, and then think to yourself, well, do I have to do anything to that model to make sure it stays relevant? Does it need tweaking, or do I need a new model? And then there's our web services. So these are web services that we can actually connect to using Excel. So I'm not going to add in any at the moment. In fact, I will just add flow site cleaning data. Could add that. I'll add this one. Past Summit 2015. So when I've clicked on my experiment, it's taken the data set and the experiment as well. So what we can do is create experiments. So I'm not going to run this one just now. I'm going to take you through it first of all. What I'm going to do is decrease it in size so you can see it a bit better. So what we can see here, the first thing we've got here, these are our data sets. We know it's a data set because it's got this little data icon at the left-hand side. And when we click on each of these tasks, we can see the properties at the right-hand side. So this is a default data set, one that's a sample data set. One is the restaurant ratings, one is the customer data, and the other one is features about that particular restaurant. Then we start to do things with our data. Like I said earlier, we can actually do things with the data in order to clean it. So what I've done here, what's happening here in this experiment, is we're splitting the data. We're splitting the ratings, and we're splitting it 50-50. And we get that from the property at the right-hand side. So it's not actually expressed as a percentage, it's expressed as a decimal. Now the reason we're actually splitting the data into two data sets is that 50% of the data will go to training the model. And this is a recommender model. You probably use a recommender model every time you log on to Amazon, and it says, if you like this, then you like that. It's that sort of thing. So you actually use machine learning every day without realizing it, and a recommender will do the same thing. You click, you put your thing in the basket in Amazon. It could be something like, say a bucket for washing. That goes in your basket, and then it'll come up with a little thing that will say, here's a bargain, you can buy these two things and you get a bit of money off. And then you get another part that says something like, people who bought this bought that. So that's association as well. It's looking at things, people who bought different products and what went with them. So that's what the recommender model actually does. But in order to train the model, we have to give it some data to get started. And then what we've got here is the second part of the data. This is the test data. How well did the model actually perform? So that's what that's for. So when we run the experiment, there's a little button down the bottom just to run it. This one is finished running quite quickly, and we can see that from the top right-hand side here. So once I'm just going to move the properties out of the way. So once we've got our data and we've run our experiment, we can actually see the outputs of each one. So as we go along, a bit like you can do an SSIS, you get an SSIS. We have a data viewer, I'm sure you've seen that, where it allows you to see the product of each component. AzureML gives you the same thing. So what we see here is the result data set for restaurant ratings. It's given as a place ID, latitude, longitude, and gives us a price. It also does some descriptive statistics for us, which are over here on the right-hand side. Now, it's something that I don't see people do a lot in business intelligence, and it's actually a really, really useful thing to do, and it's certainly something you should do when you're starting AzureML as well. I know it sounds like the boring stuff, and usually people don't do this when they start to look at their data, but it's a very key thing. For a start, it tells you the minimum and the maximum values for the data. That can be really key when you're looking for data that's wrong. So I did an example I've used before, but explain the example I have in my head is I was asked to look at average bed days for people in the NHS with a particular condition. Let's say it was diabetes. Now you think, well, that's going to be quite easy. I'm going to add up all of the days that people spent in hospital, or nights rather, all the nights that people spent in hospital who had diabetes. And I'm going to divide it by the number of patients, and that will give me average number of bed days. It wasn't that simple, because when I looked at the min and the max, I could see that the minimum value was minus 189. And the reason for that was somebody had swapped the admission date and the exit date. The release date when the patient was released from hospital, swapped them around. There's actually a lot of the data was like that when I looked at it, and you can't do an average when data's like that. So at least then, and then of course you go to the customer and you say, a lot of your data's dirty, and they say, no, it's not, it's absolutely fine. And then you have to sort of go through this process of saying, well, actually it is because nobody spends minus 189 days in a hospital. And then you start, it's almost, at that point, it's a people process rather than a technology thing. You're having to explain to people their data's wrong and why. But doing the min and the max will uncover so much of your data problems. You'd be surprised. So I found, and then I found a really silly example that somebody did in Excel once. What they did was they thought the mean was the middle number in a column of data. So I looked at it and I saw they hadn't used the median of the column of data. What they'd done was choose the middle number. And that might be fine if you sort the data in ascending order. Because when you calculate a median, you're supposed to get the data, sort it in ascending order, and you pick the middle. And that should sound straightforward to most people. But what they'd done was, instead of using the median calculation in Excel, they'd actually chosen the middle cell in this row. But anytime you sorted that column by anything else, the middle number actually changed, so that the median was completely wildly different every time they sorted the data. So when I saw that, at least I could go back and fix it, but it told me that there was a lot wrong with the processes in place as well. Another key thing is missing values. If we've got time, I'd like to show you an example of that. Missing values can tell you a lot about the business as well. But the thing is, when you actually start to visualize data, it's not always very clear that missing values are not there. I'll give you an example. This is for missing values, so we'll say for a minute that this is time. And this is a value. What can sometimes happen with missing values, depending how they've done the chart, is if you do a line graph, say it looks like that, and you're actually missing this data here. The line chart can actually just look like it's gone straight across. People will assume that it's the same number in here as well, and it's actually not always the case. So that's a bit of a problem. Obviously the value could be absolutely anywhere along there. Or sometimes what will happen is this data will not be in there at all. So you could be missing something on the x-axis here. And I tend to see that quite a lot. So I'll see something like year 2000, 2001, 2, 3, and then maybe 5 and 6 will be missing. Then 7, 8, 9 will be present. But because this whole tranche of the line chart is missing, people don't realise that it's missing. And it's not representative. So something with missing data is actually a key thing. And that's why when we look at it in AzureML, it spits it out specifically. Because if you have got missing data, you need to go and look at that. Otherwise, your visualizations will be wrong. People will be making bad decisions on bad data that's not there. Feature type and numeric feature, that's important for things like Power BI. We want it to recognise that that's latitude and longitude, for example. So what we can do is once we've trained our model, we can save it as a trained model, and then we could deploy that to production. We could visualise the output as well. This really doesn't tell us very much, and it's not something that you could actually give to a business user either. They're not going to be able to understand that. So what we need to do is look at the very last step. We've got the value weight recommender here, and this is the output which compares the test and the training process. So when we look at this one, it gives us a result here, 0.92. This would be the output that would start to say to you how accurate the model is, which according to this would be 92%. In reality, if something was 92% accurate, I would start to think actually it's almost too accurate. If I gave that new data, would it still remain as accurate? So it's called overfitting the model. It fits exactly the case that you've given it, but may not get you to new data. What will it do? So if this was real life, I'd look at that and I'd want to throw more data at it to see what it did. Because the reality is 92% it just feels a bit high as a rule of thumb. It depends what you're doing, but I would want to test that anyway. We start to visualize the data there. So once if we were happy with this, we could train the model and we'd get the model trained here. So we can see here I've got one trained model here, and I would be able to access that and use it in .NET or something like that. Right. So we can search as well, so I want to search for SQL Pass. So you've got 2 here. I'm just going to make that a bit clearer. So the reality is when you start to build these experiments, they start to get more complex. What I strongly suggest you do is that you think about cleaning your data before you put it in AzureML. If we want actually to produce more visualizations that look like this, which we're going to cover. But you want to make sure that you are able to validate that data outside of AzureML. I tend to build enterprise architecture solutions, not focus just on one technology, doing one thing. I need to stand back and look at the data and think, right, so I've got this data, how can I analyse and look at that, not just keep it holed up in one system? Because the truth is, as you probably find, people in organisations got different technologies, and the data is very siloed. The technology around the data is very siloed as well. So I want things in AzureML, but I want to be able to look at that data, the raw data in Excel, for example. So if you can tidy up the data, it means you're not having to tidy up the data in AzureML, not having to do it again in Excel and SQL Server, wherever the data happens to reside. It's just easier to do it in one place. Right, so I'm going to go back to the slide. Okay, so I'm going to blast through that. Connecting to data. So this is coming back to your question here. Connecting to data, obviously, the whole thing is going to fail if it can't connect to data. So I have spent a little time in a section on this, and that's why. So when you actually run experiments in ML Studio, that's when you're getting charged. Okay, so the rest of the time you're just getting charged for the storage that you're using. So that's something to be aware of when you start running lots of experiments. So we're going to talk about getting data into AzureML. Now, in terms of our CRISP-DM methodology, I'm going to keep coming back to this as a backbone. Data understanding is at the point at which, according to the methodology, we start to look at getting our data into the system. So it's a key part of the data understanding phase, and it usually involves the integration of multiple data sources because we live in a messy world of data. That's how it works. So we can have data from an online source. The reader module allows us to load data which resides outside of Azure Machine Learning. So it connects, imports, and it stores the data depending on which type of format of data that you've actually imported. Oops, sorry. So the first data source is web URL via HTTP. So you can use this source if you're loading data that's already in CSV format and TSV format, which you can accept. One is R format, so that's more semi-structured data sources, and that's if it's hosted in a web URL via HTTP. So this on its own will get you different data sources. We can also get data that's stored in Hadoop. We can access that using a Hive query. I don't know if you've ever used Hive, but if the way that I envisage Hadoop is it's more like a big data attic. It's a place where you can shove data, more or less, in whatever format it's came in at. Now, if you envisage it a bit more like Windows Explorer, so you've got a folder on Windows Explorer, it's got data in video format, it's got data in text format, you've got Word documents in there. Hadoop's a bit the same. So it's more a file storage system for storing the data. You have to, so because it's in that format, you need some way of digging in that file and structuring the data so you can see that data through a lens, and you can start to make sense of it for querying it. And that's what Hive does. It gives you that lens in order to see your structured, unstructured, and semi-structured data. Hive is called HQL. It's very similar to SQL, and that's deliberate. It allows you to use things, familiar statements, such as select statements, in order to extract the data. Now, we could spend a whole hour talking about Hive, but it's not the focus. We're on AzureML. I've got some slides up in SlideShare if people want to go and look at that to see what Hive is. So I've got plenty of information on that. But the basic key point here is if you've already got Hive queries and you've got Hadoop set up, you can use that with AzureML. And it basically means you can get your data from distributed storage in Hadoop. Coming back to your question, yes, you can use Azure SQL. You can use it also to write data as well. I really like Azure SQL. The reason for that is I'm finding that a lot of DBAs are getting so maxed out with the sheer number of databases they need to look after. I spoke to someone yesterday who said, well, a few days ago, said they were looking after about 1,000 databases, and it's very hard when you're working so reactively like that to say, well, you know what, I'm going to do something proactive, that I'd like to manage this data asset in a more proactive way. So I like Azure SQL because it meant that some of the data could just be hived off into Azure SQL. They weren't using a lot of it that much anyway, so it made a lot of sense to do that. So you can read tables, you can read views if you want, and you can read queries that use Azure SQL as a data source. You can use Azure Table as well. Now, that's tabular data, which is stored in Azure SQL. It's a service. So it allows you to have non-relational, flexible data, which is very massively scalable as well. It's not very expensive. The amount of storage, the amount you pay for storage in Azure is going down enormously. I think my personal opinion is because it's the Amazon, Google, Microsoft environment at the moment. It feels as if the industry is at a bubbling point where they're still working out who's going to be the main cloud provider. The UK is one of the most congested cloud environments in the world. We have more cloud adoption here, one of the most cloud-friendly countries. So it seems that the amount you pay for storage is just going down and down and down. And Azure Table Service is one area where it's very, very, very cheap. So if you infrequently read large amounts of data, then you might want to consider the Azure Table Service. It reads data from NoSQL storage, and it's already got built-in and declared data types, such as integer, date, timestamp, these the sort of things you're familiar with. So if you haven't looked at Azure Table, I suggest that you go and have a little look at that. Another one is blob storage. Now, blob storage contains data as images, unstructured text, and binary data. It's very cost effective as well to expose data or to privately store application data as well. You can access your data from anywhere using HTTP or HTTPS, and you can use it in AzureML Studio as well. So if you've got lots of data in SQL Server, you might want to consider is there any way using blob storage as well. It allows you to read the blob files. You can use it in ARF format, ARFF format for storage. And when you do that, the columns are mapped from metadata taken from the header of the file. So if you are using a CSV format or using TSV, what AzureML does, it will do the same thing that Excel does actually. It will read the first so many number of rows of data, and it will try to work out the data type from there. Okay. So the way that it ingests data and how it recognises the column types depends very much on the file format they're giving it to look at. And the last one is data feed providers. So we can use data feed providers to access data and pull that in. What you can do as well is if you're using R, you can use some of the R packages to download data using some of the APIs. So an example of that is the World's Data Bank. The World's Data Bank is a wonderful data asset. It will give you lots of opportunity to go and pull data down using R packages, which are already free and downloadable from the internet. So we can take data from an online source as well. So the reader model allows you to load data which exists outside Azure if you want to do that. It allows you to connect and import data. So we've got some offline data sources as well, which are not contained in AzureML. So there's quite a rich asset, a rich availability of data sources that you can look at in AzureML. So the obvious ones, like everyone else, CSV, TSV, and text. You can also use this format as well, SVM-Lite. I personally haven't used it, but it's one that you can use. Our format seems to be very, very popular at the moment, and it's just basically the file comes in, it's got headers on it, and it reads the headers in order to understand what the column types actually are. You can take in data from R objects as well if you use R, and then you certainly can extract data. It's just basically it's called an R data file. That's how you can use that data source. You can import data from an R workspace as well. When I've tried to use that, I haven't seen the workspace task work very well. What I tend to do is use R scripting and use that module and do it that way. You can use zip files as well. Now a key thing which is in AzureML is if you upload a zip file as an R package, I'll show you this. So when we look at R, R downloads lots of different packages for its use when you've asked it to do something. Some of those you'll have to manually install, but if you manually install some packages and it's got dependencies, it can automatically go off and get the dependencies for you. Now those tend to be downloaded as zip files. So you can actually upload packages into AzureML as well. Now what you have to do, and it's a very important thing, I spent ages trying to work this out, is you can actually you need to zip the zip file again and then upload it to AzureML. So even though the package file comes in, is downloaded as a zip, it's actually expecting a zip inside a zip, so you need to rezip it again. It doesn't sound intuitive, and there was a very good reason for it, which I can't remember right now. But the takeaway point is uploading any more R packages into AzureML, zip them again. Okay. So a quick demo summary. I'm going to jump back into Azure Machine Learning. Any questions so far before I jump in? No? Okay. So bear with me, I'm just going to... So... Okay. So what I've got here is a file called WDI zip. So basically that's just a zip file. Where did I get that? I'm going to show you. World Data Bank. So the world's data bank is a fantastic way of getting lots of data just for practice purposes. So if you just want to use some data and try and understand, use it for any sort of data source, I tend to use that. The World Data Bank on Twitter and Facebook, they've obviously got tons of data, and very often they've got some quite headline grabbing data sources as well. So it's the sort of thing that you can pick a headline, pick some data, and just try and work your way through some of the examples that are available. So the world data, you can access it using the WDI package. So when you download packages in R, there's usually a lot of documentation about each package, and it basically looks like this. It's a PDF file. So you can use the WDI package in order to add extra add-ons to R. We're going to cover RStudio in more detail in a little while. I'm just giving you broad brush strokes just now so you can see it. So what I've got here is I've downloaded my package and I've uploaded it to R. And the way that I do that is go to New. And it's not very intuitive, but you have to go to Dataset. Yeah. And once you've gone to Dataset, you can then upload your local file there. So let's see, so if I go to WDI, I can download it straight from the site, from CRAN. So that looks like it's not the right one. So I could get it from RStudio as well, and it should be in my file explorer. Right, I'm just going to spend that off to look for that. So in the meantime, what am I doing with my script? I can choose my file, I can upload it. It comes in as a zip file. I've got a script in here. I'm going to talk very briefly about the scripts. Don't worry about learning all of the code. I do keep meaning to blog this, so it will be up there at some point. Now, the first thing to notice is in any RScript package task that you have in AzureML is that it starts off with this. Now, normally, if you are not doing an RScript, these actually relate to these data sets here. I don't know if you can see that, but there's small nodes in the top of each of those tasks, and that is dataset 1. Then I've got dataset 2. Just in here. And they basically map there. So if I was using an online data source, they would map to either of these points here. But because I'm using a zip file, the way that our script works is, the way this task works is expecting the zip file to go on the third node at the end. So that's how that works. So we need to install the R package. And the way that it does that is reference. It expects everything to be. You need to specify it's been written in this SRC, this source directory, and then you give it the file name. But at that point, when you've uploaded the zip file, you need to make sure that you've re-zipped the zip, or it will not find it. It will just tell you it can't find it. So then what we need to do in R is we need to call all of these libraries, and most of the Azure ML packages are already there. There's about 300 of them, but the WDI one is not there, so I've had to upload it and then I've had to call it. And the way that we do that is just a piece of code that says library, and then you give it the name of the package, WDI. If you've ever used anything like Visual Studio or anything like that, what you've got here is you need to require, so it's not enough just to load the library, you need to require it as well. So that's how we read the offline data source using R. I'm going to walk you through the rest of the script. I've got some more. I want to break it up into chunks. So this particular bit, we've just focused on how do we upload an R package there, then how do we call it. So that's just a quick demo. I will walk through the rest of it. I just want to do it bit by bit because I know it's a lot of information just to take in all at once.
Can I ask this question?
Yeah. Sorry.
If you're running R, why are you running R in R Studio? Why do you need to do it in ML?
Due to the size of data, RStudio in R only runs the amount of data that it can hold in memory on your laptop. So
Why are you running R Studio? R server on its own.
well, you could do that as well, but the purpose of this particular session was to cover AzureML. So there are different ways of doing it. So I don't. There's a question behind the question which I'm not getting.
Yeah, I just don't understand why you're trying to run R in ML.
It depends on which it is, I think, your preferences. So if you want to use, you could set up an R server, you could revolution R server, but that's been deprecated. So you may want to go, actually, well, I'm not going to use something that's going to be deprecated at any point. R services in SQL Server 2016.
But it's not in Azure SQL.
No, that's right, it's not in Azure SQL because Azure SQL is a data store, so it's a database. But if you want R services in full-blown SQL Server 2016, then you have to use Enterprise Edition, that's right. So
in the short term, we've got R server as a solution.
Yeah, yeah, that's right. So I'd understand, well, it's up to you. I mean, my preference is to tend to go for the latest and greatest technology. The thing is, if you use AzureML, it also gives you some other packages as well. So it's not just about R, it's got other things in there too. If you want to use R in the cloud, you could set up a virtual machine and use SQL Server 2016 at that point. You could use it then.
Yeah, that's enterprise license.
That's right.
IAS on supporting patching things and that's it.
Well, the thing is, it's all about, do you use infrastructure, IaaS as a service, or are you using PaaS? So that's an architectural decision for the organisation. So Azure ML is more towards, it's more like machine learning as a service. So for some people, that would just be easier for them to use.
So AzureML scales your R?
Yes, that's right. If you use SQL Server and R services, it also scales your data, but it's looking at SQL Server data, whereas AzureML has opened it up to different types of data sources. So you may have an R file, for example, and JSON is just newly in SQL Server 2016, but it depends what your data source actually is. So if you are just simply wanting to use SQL Server 20 database as a source, then why not just use R services if you've got your models there. But if you want, I've already been through a lot of the different file types, and if you want to use any of those, then your better bet's to use AzureML. So there's lots of it depends answers in there, so I hope that helps. But if you want to use RStudio on its own on your laptop, it will only look at the data that's in memory.
There's RStudio Pro as well, isn't there?
Yes, there is, that's right, it's a server edition.
Yeah, so you could run that.
You could run that, That's more about the management of the R scripts than anything else. It's not about scaling your data. RStudio is just an IDE. So for the purposes of being fair, there are other IDEs and there are other third-party products you can buy. I just happen to use RStudio. Server Edition is more like, if you use Visual Studio Online, it's more towards that, where you're checking in your code, you've got scripts, and it's a paid product. RStudio is open source, it's free, downloadable, but that's only the desktop edition, and it will only look at the data on your laptop and the memory there.
RStudio with an IIS VM,
Mm.
because it doesn't care.
Yeah.
On a desktop or server.
Well, sorry, I didn't catch what you said.
I just said you can install our server,
Mm.
RStudio on an IIS server.
Uh-huh.
Azure Cloud doesn't care what operating system you're on.
But it's just looking at the data in the memory for the virtual machine, isn't
Yeah,
it?
so you just build a machine with lots of memory.
Yeah, exactly. But what happens if you've got terabytes of data and you've got a Hadoop system, which is a distributed file system? At that point, RStudio is going to need some other way, or you're going to need some other way of analysing all of that data. So I'm not just thinking of little data sets, I'm thinking of the really, really, really large ones. So I did something recently for an organisation who have a lot of entertainment data. So that isn't just little CSV files, there's all sorts of data in there, unstructured videos, that sort of thing.
The only reason why I ask this question is the fact that you're having to do lots of workarounds just to load a package into a... that's kind of 3 lines of code in R.
ML, it's easy to do the easy things, but I'm trying to show you something a bit harder, because I think you shouldn't come to a training session and get to do something you could have looked up in 5 minutes and Google by yourself. So I'm trying to show something that's more difficult so that I think you would learn well that way. So that's just a teaching mechanism, really. I'm trying to give you an example where we tie together, coming back to gentleman's question earlier, how do we get data in there? What happens if we don't have our package in R, but we need to use it? If you're an academic institution, for example, you can get AzureML for very, very low cost, and some of them use it, but they won't have all their packages there. So I'm doing some work at the moment with some hospitals. We're using R at the moment. So there are so many different options and ways of using it, and so many large data stores that it becomes very interesting. But it becomes a real business question: how do you find the best way of doing it? AzureML is just one option of many options. That's all it is. So I'm trying to show you more of the worst case scenario. If I showed you easy stuff, then what would be the point. So coming back to where we were, we can look at various data sources, but the point of AzureML is it's supposed to be more easy to use, and it really empowers you to look at terabytes and terabytes of data if that's what you want to do, and you could host that data in distributed architectures such as Hadoop. Okay, so I'm going to come out of that. I think that's right. We want to talk about on the current slide. Okay, oops, sorry, you don't want to see that. Okay, so 80% of your time messing around with data and data science, the quote goes, is on cleaning the data. So that's something that we're going to look at. Now it comes to the point where you can clean your data quite simply in AzureML, or you can do it in R scripting. It depends on what's wrong with your data. AzureML is easy to do the easy things, and that may be quicker for you, or you could do the harder things in R. The main takeaway point is that there are options depending on your environment. It's not funneling you down doing one thing. So what is dirty data? What should we do about it? And how do we clean data in ML Studio? So I hope you can see that all right. I've got a matrix here just with the word data in it, a bit of a matrix. So we can see there are different types of data. We've got invalids data. So if this data was only supposed to be letters, we can see straight away that some of it is in asterisks. We see we've got missing data as well. We've also got some nulls in there. We've also got duplicated data. So how do we start to clean that up? What we can do is we can start to remove the invalid data, or you could replace it with something else. Missing data, you can actually get a few options around missing data. What you can do, and AzureML allows you to do all of these, you can actually remove the rows that are missing completely. That's something I see people do a lot. On the other hand, that can mean that you're missing a whole chunk of data. And I'm going to want to show an example where we can see the missing data and work our way around that. We can also do things with duplicated data as well, and we can do all of this in AzureML using the tasks. Okay, so a quick demo of that. All right, so I'm going to go back to experiments. So where did that go? Sorry, I'm going to have to put this down to a lower so I can see it better. Sorry about that. Just searching for missing. Yeah, okay. There we go. So here I've got, it's a different source of data. What I've actually got is an R file, and I'm going to show you the data first. Now the data is taken from the ICS, one of the universities in California, and it's a data file. That's basically an R file. So we can see here it's actually census data, and it's data about people, about their earning levels, for example. So what we've got here is a metadata editor, because when we actually look at the data source, you can see there's no columns there, so it's actually quite hard to read. Where did that go? Right. Okay, so what we can see here is we've got our column names. We've renamed the columns. So they come in if it has no idea what the columns are, it's just on call 1, call 2, call 3, so on and so forth. So I'm not changing any of the data types in here. I could if I wanted, but I'm not going to. What I'm going to do instead is right down the bottom is give it some new column names. And that just makes life so much easier. We can see what the data actually is. So when we run this experiment, we can visualize the output, and it's so much easier to read now. We've got the age, we've got the strata of work, we've got the marital status, the occupation, and we've got the race and their gender. So look at the race, for example. That would give us an example. We can see down the bottom what the race happens to be in the data set. So what we can do there is, first thing we should do is our descriptive statistics. We can visualize that, and we can start to see that some of the data is actually missing quite a lot. So we can see, for example, that the class of work, we have 1,837 instances missing. For occupation, we also have 1,844 missing as well. We've also got some country data missing too. So we can do some interesting things with that, but at least if we do our descriptive statistics, we know that first of all we have some missing data. So in this project, column 1, I'm going to launch column selector. All that's going to do is going to remove a column which I don't need. In the census, they assign you a weighting for certain things. We don't need it here, so I'm just going to remove that column. Then we've got this interesting one here, which is cleaning the missing data. So we want to clean all of the columns. So what we could do here is we could remove the entire row, which is this process here. I want to talk a little bit about some of the other ones. So what we can do with missing data is, coming back to my example earlier, if some of the data is missing, you'd be surprised how many people don't look at x-axis to have a look and just double check that. They don't check the axes, they just tend to home in here first of all. But what you can do in order to visualize the data is replace it with different things. If you replace it with the median, it's not actually, you'll get a plot, so you will actually get some data plotted, and that's good. So you get actually what the data happens to be. But actually in terms of the stats, adding in the median doesn't actually change anything, it just gives more data points. It's just added in more of the same number and added in the median, which it already knows. Now, if you replace with the mode, that can actually start to change the data a little bit. The mode itself, the average, is more sensitive to outliers in the data, whereas the median is not. So my own preference is to actually just replace with the median, and then it gives me data points that we can see. What you can do as well is you can tag the data points, so you can tag what is missing and what is actually present. AzureML will do that for you. It will add in a tag for you, it adds in an extra column. And the idea there is you're doing it without having to do any coding. There are other mechanisms as well, but you get the idea. We can do all sorts of things. So we can actually clip values as well. So here I've clipped the age, so it's 75. Anyone over 75 is excluded. So I've done all of that without any real coding. I've clipped more values here. People who work more than 77 hours a week are excluded as well. I probably work more than 77 hours a week, so I wouldn't be included in this sample. So once we've cleansed that data, we can actually convert it to another data set, which AzureML can use. So you've got the data in the cloud, you've cleaned it and put it basically back into the cloud. Now, the reason a lot of cloud data is used, a lot of data is generated in the cloud, if it's intelligent sensors and so on and so forth. And also if you are moving towards more cloud architecture, because you don't want the total cost of ownership of owning tin anymore, then it makes sense to do stuff in the cloud and just put it back in there.
Can you conform the data or factory that?
Yes, you can do that. Yeah, so you can do, I don't have an example here, but you can certainly start to do lookups and you could do that, there's a few different ways to do it. You could use R or something like that. There's probably a module in here that will help you just to do that, swapping in and out. I'd probably do that at the data sources, start to merge the data. I'm doing, one of the projects I'm looking after at the moment is quite an interesting one actually, just when you talk about lookups. Looking at using Redis cache for SSIS. And the reason for that is, you know, those lookup modules in SSIS can take a long time sometimes to churn out unless you optimize the memory. We're looking at using Redis cache just to see if it would be any quicker. The initial results are shown actually is pretty quick, so that's just another thing to think about if you are finding you've lots of lookups, using open source technology to augment your business intelligence SQL Server solution. So yeah, I can't think at the top of my head, but yes, it's the sort of thing you could do. I'd probably tie it up towards the source more. So that's just a quick example. So an important thing to do, and I'm going to keep hammering on about this, is splitting the data into test and training and keeping it up to date as well. Normally the rule is 70-30, or you could use 80-20. What you have to do is split a subset, as we've seen in AzureML, and then we can test our performance using the test data. We've had a look at training and test data sets, so that split module. I won't do that again. So it's quite nice because you can use it using a component, you just drag and drop, and you just add in the integer. And that makes the modelling development work easier by splitting the data for you. So how do we improve model quality with AzureML? Well, what we can do is actually, again, coming back to the data, is about scaling and cleaning and transforming the data. So One thing that you sometimes have to do is scale the data. You can put it between 0 and 1. The reason you might want to do that is some of the modelling techniques will actually be quite badly impacted if you start to find that you're using different metrics to measure the data. So one example might be is you start to use mix imperial measures with metric measures. So we've got height in inches, and then we've got weight in pounds. And what we find is the data that's higher in value can sometimes have an adverse impact in the model because it starts to drown out the impact of the smaller data set. So you can scale and normalise the data. You can do that quite easily in AzureML. It will do it for you. The only thing I'd be careful of is some of the models will scale the data for you. So you don't want to scale it and then rescale it. Something like a neural net will actually scale it as part of the process. So if you are thinking about using any models, have a think about, does it scale the data for me? And does the data need scaling before I even start? So what we can see is the data that's closer together, they're not going to have such an impact on each other. So just some examples here. There's different ways of normalising the data. I'm conscious of time, so you can find this on the AzureML site. What you can do, a very common way, is rescaling every feature between 0 and 1. Or you could actually use a z-score, which is where you've got the mean and the standard deviation, and you can put in those for each column separately and then working out the scale from that process. AzureML will allow you to do all of these just with a few clicks. You can use a log as well. And the main point here is checking whether the model already scales the data as part of its workload. Scaling it and then rescaling it, you might have an adverse impact in the data as well. So I want to have a quick talk through some of the models, and then I'll come back to the original example that I showed you earlier with the R script. So we're going to have a quick look at regression methods. What are the different types of regression? We'll look at how we interpret our results, and then we'll have a quick look at it in AzureML. There are different types of regression. The actual origin of the term regression stems from a 19th century statistician's observation was that children's heights tended to regress towards the population mean in relation to their parents' heights. So it's really the relationship between the average of one variable and its corresponding values around it. If you're investigating one variable only, then that's just a simple regression. So that could be, how does the height impact the weight? We've also got curvilinear as well, which is basically the constancy of the ratio of change between the variables. If the amount of the change in one variable tends to remain fairly constant, then it's a fairly linear relationship. So height and weight, you plot those, fairly straight line. But if you plot the data and it doesn't fall in a straight line, then it could be curvilinear at that point. Oh, sorry, Katana keeps popping up. So we've got an example here how we could we've got a function here called GLM, Generalized Linear Regression, and that is one of the most common ones we can use in R. It's a great starting place when you want to predict a number, and very often if you're doing any modelling, using regression is just a great way to start to see how you can understand the data. It's not a very expensive one in terms of computation. If you're using R, you can have a quick look for the GLM function, and what it's trying to do is, first of all, is summarising all the variables. It finds the mean, it finds the median, and then it tries to work out what the parameters of those might be. Then it's looking for the error. So regression is a bit like a dartboard. You're trying to hit the bullseye every time. But the difference between where you actually hit the dartboard and the bullseye, that's actually the error, if you like. That's how wrong it was. So I'm just going to skim over these. I'm just conscious of time. But basically the functions in R look like this. So basically you specify your model, your function. Here we've got GLM. Uses R is really nice because it uses variables and it all comes very naturally to R. These sort of regression techniques are already inbuilt in AzureML. So you could use one of the inbuilt datasets in R. So once you've done that, you could use these models and take them, use them if you've already got them, and you can put them into AzureML. Now, I'm working, as I said, in a hospital at the moment. We've already got very, very well built and very well established models already. So the option there is, could they keep them as they are, or do any of those actually start thinking about, well, we can move some of those research facilities and look at using the cloud there. It gives people options in order to use their data. So what this particular algorithm is doing is trying to work out people's earning level depending on their age, their education number, their education level rather, the hours of week per week that they work, their gender, and it's doing that using the adult data set. And the adult data set is the one I showed you a little while ago that had no headers in it. Okay, so it's set to be binomial, which means it's got more than one classification problem to use. So once you've built a model, then what we can do is take that model and then try to work out its rate of prediction. The goal here is to use a model to identify the earning level of people, whether they were earned above 50,000 a year or whether they earned below 50,000 a year. So that's all it's doing. So when we see it's just going to predict, it's going to take the model, which happens to be called model, to keep things as simple as possible. I've got it in a new data set which is called Adult Train. I'm using the training set here, and then the response basically means is I'm expecting more or less a yes or no answer. Was the person above or below 50,000 a year? How do we know it's any good? Well, if we look at R, for example, what we can do is run the summary command, and it will start to give you some good clues. If it will come up with some results that will help you identify if the model is any good. It will work out how statistically significant the model is, and basically it does it with the stars. So if something's got 3 stars, then it's comfortable, the data is a good fit. If it's only got 1 star or half a star, then it's not such a good fit. It gives you some metrics which identify the quality of fit. So coming back to AzureML. Sorry, lost it. I've got my script here, so we've uploaded our package. You can build your own packages as well. So if you've got something custom built, you could go and do that. No reason you couldn't do that. So what you can do is use your functions here. Sorry? Oh, right, okay, sorry, thank you. Come on. There we go. Okay, thank you. I'm just going to zoom back in again. So coming back to our example of the World Data Bank, what we're doing is I'm taking some data here. Now the World Data Bank has got all sorts of weird indicators. They're a bit like finance indicators. They've got a lot of them. So what I've done here is I've just taken, I think that one I've taken is life expectancy. I'm just going to double check. Sorry. Yeah, that's life expectancy. And I've done that for Rwanda in 1990 to 2015. You probably remember the 100-day war. 1 million people died, and at that point the life expectancy for Rwanda went down to 19 and a half. It was such a decimating effect on the population. So I'm not going through the detail of the function, but basically what I've done is taken a function, and if it sees any missing data, what it's going to try and do, it's going to try and guess the middle point of that data. So if the life expectancy was 20, and then it was 2 years later was 40, we're trying to work out what the data is for the missing year. So what happens then is we write our code, and we bind the result to a data set, and then we output the results of that data. And we can write out the results to a CSV file. So what we can start to do is output that data to a CSV file. Then it would try and help us to work out, we could then visualize that data using Excel if you wanted to do that. So, sorry. I am just conscious that I have just run out of time. So for that, I do apologise. I wondered if anyone has any questions. I was supposed to finish at 10:30. What I'm going to do, in case you're interested in coming back the next session, is we're going to cover Cortana Analytics. If you are interested and want to follow that along with me, if you've got your laptop, get the Wi-Fi code, join with me, and we will go through that together as a sort of more hands-on activity if you want to do that. You don't have to join in with me if you don't want to. If you want to sit and watch, that's fine too. But that's what we're going to talk about in the next thing. So basically, the purpose of AzureML, you've got all of these machine learning models here. You can roll your own in R. You can use the inbuilt ones if you don't have R skills or data science skills in your organisation. They are getting more expensive, obviously. And if you, what I like about it is it's an enabler. I've worked with large organisations using machine learning and also really small ones as well. And it means everybody's got access to large amounts of data. It's a leveler and an enabler. So if you have any questions, come and see me. Otherwise, I'll be finishing. We start again in 15 minutes, or I do anyway. All right, hope you enjoy the day. Thank you.